In this video, we will talk about coding job interviews, and I will give you many tips on how to succeed in interviews with big companies like FANG or MANG, and also how to succeed in interviews with smaller companies and startups. So let's get started. Hello everyone, welcome to this video. My name is Ari, and today I will give you several tips on how to approach coding and tech job interviews. I'm currently a software engineer at Google, and I also teach courses on algorithm design and data structures to students at the University of Southern California. The tips in this video are based on my experience of participating in so many job interviews, both as an interviewer and the interviewee, in bigger corporations such as Google, as well as smaller companies and startups. I hope you find them useful, and if you do, please go ahead and like this video, share it with your friends, and also don't forget to subscribe to my channel. All right, let's get started. Before I start, let's have a quick disclaimer. All the tips in this video are only my personal ideas. What worked for one, what worked for me may not work for you. Please do your own research and take the tips in this video at your own risk. First things first, what should you do a few weeks or a few months before your interview? That brings me to tip number 0, which is you should know your basics. You should be very comfortable with basic algorithms and data structures in a way that you can implement them really quickly with minimal thinking. And please do everyone a favor, if you're not familiar and comfortable with any of these algorithms and data structures, just do not go to any interviews and spend the time instead on learning them. These days, not knowing any of these algorithms is a huge red flag and can have very bad consequences. Having said this, let's move on to tip number 1, which is practice, practice, practice. So assuming you got your basics right, then you can use websites like LeetCode or HackerRank and practice solving algorithm problems. Pick 1 or 2 problems per day and gradually get great at them. I know people who solve at least 200 or 300 problems from these websites before even considering going to job interviews. The other thing that you can do is to practice either mock or real interviews. Once a week or twice a week, you can ask a friend to sit down with you and pretend they are a very meticulous interviewer and ask you algorithm problems. Another thing that you can do is to actually go and do real interviews. You can do this by scheduling your most favorite company at the end, and before that, schedule some real interviews with some other companies in which you're not as interested. The experience that you gain from here will definitely serve you here. Moving on, few hours before the interview. Let's say you did the practice and this is the morning of your interview or the night before. What should you do just a few hours before you get into the interview session? My recommendation here is to not put your brain under pressure and make sure you're relaxed and rested. However, there are a couple of things that you can do that they might help you. The first thing that you can do is to just review your basics. So on the morning on your interview session, you can just sit down for 15 minutes, 20 minutes, or maybe an hour and try to write down or re-implement the familiar algorithms that you're supposed to know one last time. For example, you can write DFS, your sort algorithms, your graph search algorithms, the binary search algorithm. And the reason for doing this is that, first of all, it makes you warmed up. And given that you already know these algorithms, it probably wouldn't put a lot of pressure on your brain, and also refreshes these algorithms so that you don't have to spend so much time in implementing them at the interview session if you're asked to do so. Keep in mind that usually it's expected that you know these algorithms and use them as black box. However, sometimes the interviewer might ask you to implement them. And in that case, you have to be very quick. There's usually not that much time to think about and extract this algorithm from scratch. You have to rely on your memory as much as you can. And the second thing that you can do is to solve just a very easy question. And the goal for doing this is to just warm up and make your mind to get into interview mode. Websites like LeetCode and HackerRank have a lot of questions that are marked as easy. You can pick one of those, or better than that, you can pick one of those that you have solved maybe a few weeks before so that you don't have to think too much, and just try to resolve and re-implement them with the goal of warming up. Every athlete spends some time to warm up before getting into a race. So if that's the case, why shouldn't you warm up before getting into a very intense and long interview that sometimes takes 4 or 5 hours and requires very focused and intense thinking? Here I'm showing a very famous easy question like FizzBuzz that I like to solve before going to any interview, just so that I know that my mind is warmed up and ready to answer any questions. So let's summarize all these in tip number 2, hours before the interview, review your basics and warm up. Make sure your mind is rested, and keep in mind that there's no time to figure these algorithms in the interview, and for the most part, you should rely on your memory. Up next, the interview. What should you do at the interview? If your interview is in person or it's on video, which is usually the case with big companies, the interviewer starts with some greetings and some small talk questions. And their goal usually is to make you comfortable so that you feel confident and comfortable to solve their question. However, your goal should not be answering these questions. Your goal should be not wasting time and getting to your main question as soon as possible. So if they ask you these questions, do not tell them your life story and try to move on as soon as possible. This brings me to tip number 3, which is minimize the chit chat. Your time is limited and you want to get to coding as fast as possible. Yes, you do want to stay polite. You still want to greet them as well. But what you can do is to simply say, my day was great and I'm ready for the questions. Given that their goal is to make you comfortable and ready, once you say something like this, they will realize that you are ready, and as a result, you can get to your question in the first 30 seconds or in the first minute. One thing that I want to note here, and you probably already know, is that as interviewers talk to you, they take notes. Whatever they write in their notes can change your future. And unless you're interviewing for sales or customer support, there's probably never a note like this in the feedback notes of a technical interview. So you will never see something like this. So if chit-chatting and small talk doesn't give you any credit, why would you waste time on it? One more thing that I want to add here is that your interviewer, especially in bigger companies, is a person that you may never see again, even if you get the offer and even if you start working at that company. So you should probably save all of your questions about that company to your recruiter and save the time to get to your coding part. All right, let's move on to the questions that you might be asked in a tech interview. Sometimes the interviewer might ask you a very, very simple question. Here is an example. The interviewer asks you to write a sorting algorithm, whatever you like, just a sorting algorithm. In this case, you might think that you're lucky the interviewer asked you a very simple question, and if you answer this, you're off the hook and you're one step closer to the offer letter. So you might quickly write a sorting algorithm, maybe selection sort, quick sort, whatever that is easier for you to implement, and think that you're done, and go home, tell your friends that, hey, I did great, I got lucky, I interviewed with Google, Facebook, Amazon, and all they asked me was just a simple sorting algorithm. So my advice for you is that do not fall for this. This is not the case. You will never get an offer letter by writing a simple trivial algorithm like this. Let's get back to the feedback notes and see what would happen if you actually write the sorting algorithm. The only note that you would get would be, hey, the candidate was able to implement a sort algorithm in the 45 minutes that I gave them. And this will just give you, meh, yes, maybe, yes, maybe, yes, maybe they were able to write an algorithm, but let's see if we can find a better candidate. So what should you really do if they ask you a very simple question? And that brings me to the next tip. Tip number 4 is that if you got a question like that, do not jump to answering that question. Instead, start asking questions from the interviewer. What do I mean by this? Usually, it is expected from you to ask questions, and the interviewer wants you to ask them questions. And especially if they give you a simple question, they do expect you to ask them a lot of questions. Here are some of the example questions that you can ask. How many items do you want me to sort? What are the types? Are they floating points or are they just integers? What is the range of the values that you want me to sort? What is the constraint on the runtime? What is the memory constraint? Is the sorting external or internal? Does the stability of the sort matter? And depending on the questions that you ask, the interviewer might give you answers. As they give you answers, make sure that you take notes of everything. So make sure that you do write down all the assumptions. The interviewer might tell you that the input is a vector of integers, so you don't have to sort floating points, for example. The values are all between 1 to 100. And the input size can be very large, but it still fits in the memory, so we should probably only think about internal sort. Now, having these assumptions, you can enter a discussion with your interviewer. You can say, hey, I can write selection sort, which is very simple, and it doesn't take that much memory. Or I can write heap sort that can have a better worst case runtime complexity. Or I can write merge sort or quick sort, which is one of the fastest sorting algorithms. Or in this case, looking at the assumptions, maybe I can use counting sort because I know the inputs are integers. And you also told me the range of my items are only between 1 to 100. And again, do not forget to write down all your insight. So here you say probably counting sort is the better algorithm. Notice by asking a few simple questions and providing the options, what you would get. Let's go back to the feedback notes. The interviewer might notice that you know most sorting algorithms and you're able to talk about the pros and cons of each one. You asked several questions about the data, and based on them, you were able to pick the fastest one or the most suitable one, in this case, counting sort. And hopefully, once you implement counting sort, the interviewer will write down that you were able to implement that algorithm. And finally, if they're nice, they can even add a bonus saying you had very good communication skills and you were able to participate in a technical discussion. And this is very important, which brings me to the next tip, which is make the interview a discussion, not a boring interview. The best interview is an interview in which you turn the tables around and you make the interviewer enjoy the discussion. They have tons of things in their life going on. They usually don't get extra time for interviewing you. It's something on top of a lot of other action items that they have to do. So in most cases, being in an interview session for the interviewer is one of the last places to be. So if you can turn that to a discussion, and if you make them and if you help them enjoy the discussion, chances are you will get a very good feedback. Let's compare the two cases side by side. Candidate 1 quickly implemented selection sort and they got this feedback. However, candidate 2 participated in a discussion. They got many more feedback items, and their code, which is usually attached to the notes that the interviewer is taking, looks much more professional and much nicer. I'm not going to say anything. Put yourself in that company's shoes and tell me which one would you hire, candidate number 1 or candidate number 2. They both probably have the same knowledge, only candidate number 2 was better in presenting themselves and turning the interview into a technical discussion. And this brings me to tip number 6, which is maximize the interviewer's data points. As I mentioned, their notes can change your future. The more questions, the more technical questions that they ask you, the more data points and the more feedback items you will have in this form. Now, before you telling me by asking too many questions, I might waste all my time on questions and not get into coding, let's move on to tip number 7, which is no matter what happens in the interview, you should start coding in the first 10 to 15 minutes. If you're chit-chatting, if you're asking questions, if they are asking questions, if they're explaining about the company, no matter what happens, please make sure that you start coding after 10 to 15 minutes. Because especially in big companies, you will not get in, you will not get an offer, you will not pass the interview unless you code and your code is correct and has acceptable quality. Moving on to harder questions. Life is not always nice, and the interviewer may not always ask you simple questions. They might actually ask you harder questions that are not obvious at first. What should you do in those cases? Let's look at this with an example. So let's say your interviewer gives you this question. You are in an ocean. The ocean is modeled with a grid like this. The grid is square. It has the same number of rows and columns. Inside the grid, there are some sharks and there is an island. Your task is to swim towards the island while you try to keep your distance from the sharks. And in fact, the question is asking you, what is the maximum of the minimum distance that you can maintain with any shark as you get to the island? Let's repeat this one more time. What is the maximum of the minimum distance that you can maintain with any shark as you get to the island? Let's see some examples. If, for example, you take this path, you will cross path with this shark. That means at this moment, your distance to this shark would be 0. So your minimum distance overall during this path to any shark would be 0. However, if you take this other path, your minimum distance to this shark would be 1 at this location, and your minimum distance to this shark would be 2 at this location, and the minimum between these two cases would be 1, which means as you go through this path, your closest distance to any shark in the ocean would be 1. Here is another alternative where you can take this other path, and in this case, your minimum distance to any shark would be 2 at this location. So the question is asking you, what is the maximum value of this minimum distance? We know that it could have been 0. We know that it could have been 1. We know that it could have been 2. The question is asking, what is the maximum of this value? So how would you approach this question, and how would you solve a question like this? This brings me to the next tip, tip number 8. Make sure before answering, ask clarifying questions and accurately specify input and output. So your task here, your main task is to first understand the question. Make sure you don't misunderstand the question, which can have very bad consequences. Notice that chances are you don't understand your interviewer. Maybe in some cases your interviewer has a different accent or they don't use the phrases and words that you're familiar with. So don't be shy, ask them to repeat. And if they repeat and you still don't understand, you can ask them to write or type what they said so that you can understand them. Understanding is the most important thing here, and that's why you ask clarifying questions only so that you know that you understood it correctly. Once this is done, write down the function signature. Usually, if the interviewer is nice, they will give the function signature to you. However, sometimes they just describe it as I did, and it is expected from you to write down the function signature yourself. So let's go back to our interviewer. They ask you to write the shark algorithm. You should ask them clarifying questions and also try to exactly specify your input and output. By asking these questions, you might get from something like this, which is in English, and maybe some diagrams, to something that is more accurate and it's in code. So now we have a function that takes a two-dimensional array or vector of characters. The sharks are specified with character S, the island is specified with character I, and you are specified with character Y. In this video, I'm using C++, but feel free to use your favorite language as you're watching the video. By converting the problem statement that was described in English to code and accurately specifying the input and the output of your function, first of all, you might get one positive note from your interviewer that you were able to quickly specify the function signature. But more importantly, you have a starting point for coding, and also you are ready to ask more questions if necessary. In this case, the other clarifying questions would be, hey, What directions can I move inside the grid? Can I just go up and down, left and right, or can I also go diagonal? What about the sharks? Can the sharks move too, or is it just me who's moving in the ocean? And define distance. What are we using, Eulerian distance or is it Manhattan distance? So again, hopefully your interviewer will clarify this with you in something that feels like a discussion. And again, make sure that you take notes of everything and write down the assumptions. So let's assume that the sharks do not move and it's only you that is moving. The sharks are staying where they are. And you can only move left, right, up or down, and no diagonal. And also by distance, we only mean Manhattan distance and not Eulerian distance. And also notice that if one location has distance 2, for example, of this shark and distance 4 from this shark, as you pass from this point, your minimum distance from all sharks in the grid would be the minimum of 2 and 4, which is 2. All right, we clarified everything. How can we get to the solution? What is the process of moving towards a working solution? That brings me to tip number 9, which is produce some examples. Sometimes the interviewer might have given you some examples. Make sure you go over them and if necessary, provide more examples. And this is especially important and helpful if you don't know where to start. If you don't know where to start, the first step would be producing examples. Make sure your examples cover simple, very simple and obvious trivial cases first. Then move on to hard cases and corner cases. As you start thinking about the algorithm, first start thinking on simple and obvious cases, and then move on to the general case and harder cases. In this case, for example, we can think about a very simple case that, hey, what if there's no sharks in the grid? What is the maximum of minimum distance to any shark? So this is either given to you or you can make an assumption and double check it with your interviewer. In this case, we assume that this value is 2n minus 2, n being the number of rows or the number of columns, they're equal. And the reason we set it to 2n minus 2 is that this is the longest distance that you can have inside this grid, which is from this point to this point. N in this case is 5, 2n minus 2 is 8, which is the distance of going from this point to this point, and the count would be going here, then here, which is distance 2, 3, 4, 5, 6, 7, 8. And remember that these are Manhattan distance, not Eulerian distance. And you can only move horizontally or vertically and no diagonal. Here's another example where the island can be much farther from you. And in this case, again, the minimum distance you can assume to be 2n minus 2. Here's another simple case where you only have one shark and the shark is in the farthest place from you and you're already on the island. In this case, you don't have to move, you're already on the island and your distance from this shark is 2n minus 2. Now let's look at a harder example, which is the case that the island is blocked by the sharks, and in order to get to the island, you either have to go from this way or from this way. Remember that we cannot go diagonal. So in this case, you will co-locate with one of these sharks, and as a result, your minimum distance to a shark would be 0. Here is another similar example where you start from here and you're already surrounded by sharks. Again, in order to move, you have to cross one of these sharks, and in that case, your minimum distance to them would be 0. Now let's move on to tip number 10, which is start from small examples and also keep your examples manageable as much as you can. What do I mean by this? Notice that as I was going through my examples, I used a grid that was 5 by 5. However, I could have used a grid that is 3 by 3 instead and still consider the same case. Using this smaller grid will make my example manageable. In case I want to test my algorithm on my examples, I will have a smaller array, a smaller vector to apply to my algorithm, and that will save a lot of time. So while you still want to keep your examples general, see if you can keep the size of the example as small as possible. Moving on to tip number 11, I've already talked about this, write everything down. As you talk to your interviewer, try to stay organized and write down everything. I personally like to divide my notes into these sections: the assumptions, the examples that are either given to me or I come up with myself, all the insights that I find and I double check with my interviewer, all the improvements that I make to my algorithm, just the improvement idea, which I can write in probably one line, and hopefully at the end I can test my algorithm and write down the steps that I took to test my algorithm. In the old days, and even sometimes now, you're asked to go to a whiteboard and write everything down there. However, try to avoid this at all costs. It is year 2022 and request a laptop instead of a whiteboard if possible. And I can't stress this enough. I know some of you guys are probably more comfortable with a whiteboard. However, a lot of big companies have moved on to laptops, or if you request from them, they will accommodate you with a laptop and they will allow you to answer your questions on a laptop, just like the way you do on LeetCode or HackerRank. This will allow you to stay organized. Delete something or insert something inside your notes would be much easier and cleaner compared to a whiteboard. So bottom line, stay away from the whiteboard. All right, let's go back to our notes. So far, we wrote our assumption, we wrote the function signature, we added one new section here, which is the examples that were either given to us or we generated ourselves. So we talked about several examples. If there's no shark, if there's a shark that is far away, and the impossible case that the sharks are around the island, or you're surrounded by them, in that case, the output should be 0. And one more time, remember that you're doing this because these days your notes get attached to the interviewer note and will be sent to a hiring committee to decide. The hiring committee will look at your notes and they will observe that you were organized, you wrote everything, they will read your notes, they will figure out that your notes make sense, and hopefully they will make a positive decision about you. All right, enough talking about notes. How do we get to the solution? Let's go back to our examples. On the one extreme, we saw that the output is 0 when you are surrounded by sharks or the island is surrounded by sharks. And on the other extreme, where there is no sharks, we assume that the output is 2n minus 2. Just by looking at these examples and by staring at them, I hope you will have the same realization that I had, which was, hey, I can bound the output of my algorithm to be between 0 to 2n minus 2. So no matter what algorithm that I write, no matter what my solution is, it is guaranteed that the output is between 0 or 2n minus 2. Insights like this don't come from thin air. The reason we have it is that we started from examples. The examples that you created are guiding you to come up with this insight. So please remember that in the absence of any insights, any realization, come up with examples and look at them and try to find some sort of a relationship or a pattern, or just try to solve the problem on the most simple case. All right, back to our insight here. What would you do with this realization? Yes, you guessed it right. First of all, take note of it and write down in your notes under a section called Insight and mention that it looks like I can bound my output between 0 and 2n minus 2. And again, if your interviewer is nice, they might also give you a bonus point just for this. All right, we were able to bound our input. How do we get to the solution? There are two cases. You might already have a solution in mind, or you don't know where to start from. If that's the case, let's go to the next tip, tip number 12. Iterate through your algorithm knowledge. If you don't know where to start, you already thought about your examples, you started from the simpler example, you got some insights, you still don't know where you should start. Maybe you can just quickly iterate through your algorithm knowledge and see which one you can apply here. For example, you can say, hey, this looks like a graph traversal, so maybe I can use a DFS or BFS. You can think about if any sorting can help you. Can I map this to trees, which is unlikely in this case? Can I write a recursive function? Or once I write the recursive function, can I apply dynamic programming or backtracking to it? Or maybe because the question is talking about minimum distance, maybe I can use one of the shortest path algorithms to solve this. Or maybe I can use some sort of searching to get to the answer. So just quickly go over your algorithm knowledge. As a side note, I usually like to tell my students that every graph algorithm problem that they see, they should probably first think about DFS or BFS because they're able to solve a lot of problems. And that brings me back to the next tip, which is actually the repetition of tip number 0. And I repeat this here because it's important. You have to be sure that you're comfortable with these algorithms. If you are lucky and the question is mapped to one of these algorithms here, chances are the interviewer asks you to implement it and you have to be able to implement it very fast. There is no time to think about how BFS is implemented in the interview. You cannot waste too much time on remembering these algorithms. So please make sure you are super comfortable with these algorithms and techniques. Going back to our problem, let's say we iterated through all of our algorithm knowledge and we still don't have any good solution. In that case, please think about a two-word solution, which is brute force. Yes, nobody likes brute force algorithm. However, you should at least mention it, and chances are just talking about it or just thinking about it will give you some insight. In this case, for example, I know that my output is bounded between 0 and 2n minus 2. So you can easily mention that, hey, why don't I use brute force and check all values from 0 to 2n minus 2 and keep the maximum and return that value. Let's see how that works. Notice that if you say my output is greater than 0, this means that you have to go from here to the island in a way that you never cross this location or this location. So these two are blocked. So you can test if your output is greater than 0 by simply blocking these two locations and see if there's a path between this location and this location. Similarly, when I say my output is greater than 1, that means I should not cross any location that has distance 0 or 1 from the sharks. So all of these locations are blocked. All of these locations are blocked. Having all these entries blocked, I have to see if there is a path from this location to the island. So a path like this would work. So my brute force algorithm would be a simple algorithm in which I have a for loop that iterates I from 0 to 2n minus 1, and in each case checks to see if output is greater than the value of I. For example, when I is 0, I have to check if there is a path from this location to the island while the entries with distance 0 are blocked. When I is 1, I have to see if there's a path from this location to the island while the values in the range of 0 and 1, which are these locations, are blocked or not. When I is equal to 2, I have to check the same thing while the locations with distance from 0 to 2 are all blocked. So I can summarize the brute force idea to be iterate I from 0 to 2n minus 2 and check if a path exists using DFS or BFS. We know that DFS and BFS can check the existence of a path in a graph, and As we are doing this, keep the maximum and return the maximum value of I for which a path existed. So this brings me to tip number 13, which is brute force plus the examples that you wrote in most cases can give you insight. And in the absence of any other ideas, please do not underestimate the power of brute force algorithm. I know everyone hates it, everyone thinks it's very inefficient. However, talking about it at least enables you to provide a solution that works. Now let's go and see how we can implement this. This is our idea. However, before running DFS or BFS, we have to make sure we mark the grid so that these locations are blocked. So we have to get from something like this, which is just diagram and English, to something like this, which is in code. So you can say, I will create a new grid, which normally has value of 1, which indicates a location that is not blocked, and it has value 0 that indicates a location that is blocked. When I is equal to 0, we block locations that have distance 0, so only these two locations are blocked. And we also need to find out our starting point. In this case, the start point has row number 4 and column number 0. And the end location has row number 0 and column number 4. Now, when I is equal to 1, we should also block the locations that have distance 1. So these 4 locations and these 2 locations also should be turned to 0. Now I can run DFS or BFS on this graph and find out if a path exists between start and end. So this means I will need at least 2 functions. One, I call it create a modified grid, which extracts start, end, and the modified grid that you're looking at it on the left or on the right. And its input, it's the original grid, which was 2-dimensional vector of characters. And it takes 1 extra input, which is the value of I. In this case, value of I was 0. In this case, value of I was 1. So the output of this function, depending on the value of I, is the 2-dimensional vector on the left or the 2-dimensional vector on the right. Once we have this function, we can now write a BFS function that takes the output of our first function, which had 3 outputs, start, end, and the modified grid, and then checks to see if a path exists from start to the end. If it does, it returns true, otherwise it returns false. So your function output in this case is a Boolean. And notice that here I'm using the new C++17 feature in which you can mark the output of the function as auto, and later the function can have multiple outputs by wrapping all the outputs in an std tuple. I'll put a link in the description in my repo that has the complete implementation of these functions. So this brings me to the next tip, which is tip number 14, use functions and building blocks and implement them later. Notice that I did not immediately started to implement this function or this function. I wrote them like this, and I told my interviewer I'm going to use them as black boxes, and then once I'm done with the algorithm itself, I can always go back and implement them later. And this will help you because usually the interviewers know that these are trivial functions, and they don't want you to waste time on writing these functions. They want to see how you can use them and solve the actual problem quickly. And chances are, if you don't have enough time to implement one of these functions, it's not the end of the world. Everyone knows that these are trivial, so who cares if you don't have time to implement the whole BFS function if you were able to solve the main problem correctly. So at this point, your notes should look like something like this. You wrote the signature of the functions that you're using, and you're ready to call them in your main function, which is this one. So going back to our insight and our brute force algorithm, all we need to do is to create a loop and call these 2 functions. And that will look like something like this. I initialize the return value, the answer, to be 0, and n is the size of my input. Then, as the brute force idea says, iterate I from 0 to 2n minus 2, and then I call my first function, which can give me start, end, and the modified input vector, depending on the value of I. Then I will call BFS on the modified input, given the start and end. If the result was true, I update the answer to the max of what it was before, and I plus 1, as you saw in the table in my previous slides. Notice that this has to be I plus 1, because for each value of I, we were analyzing if the output is greater than I or not. And at the end, I will return the answer, which is either still 0, or hopefully it was updated inside the loop based on the output of this function and my BFS function. And that's it. Notice that at this point, we have a solution. Our solution is just a few lines, and we only called these 2 functions and we kept them as black boxes. Let's move on to tip number 15, which is keep track of the runtime complexity of your algorithm. In this case, as you're talking about brute force, you should also talk about its runtime. And if you think about it, the runtime in this case is n cubed. And that's because I have one for loop that goes from 0 to almost n. And you can show that each of these 2 functions can be written in O of n squared. So I have n here, n squared here, and here. The whole thing would be n cubed. It is important to mention this. Hopefully the interviewer will ask you about this. Even if they didn't, make sure you tell them. And also, you guessed it right, make sure you add that to your notes. Besides the positive notes that we saw before, now the interviewer might write down that you were able to implement a brute force algorithm you were able to calculate the runtime correctly, and you were able to implement a modular solution by calling some functions and calling them as black boxes. I understand that this is still a brute force algorithm, which is probably not the solution that the interviewer is looking for. So let's move on. Tip number 16, look for improvements. Again, as you're looking for improvements, iterate through your knowledge and see how you can improve an algorithm. There are very famous techniques to improve an algorithm. For example, you can use dynamic programming, you can use caching, you can use pre-calculation, you can use a lookup table, maybe you can sort your input in a way, or maybe you can use a better data structure, maybe you can use a map, or some sort of a tree or a balanced tree. For example, in many cases, a heap can improve your runtime, or maybe you can improve your search. Again, make sure you have a few techniques for improving an algorithm and have them in your pocket and be very comfortable with using them. So let's go back to your solution and see how you can apply one of these techniques to your code. Now, this differs from problem to problem. So you have to really look at your code. You have to probably be lucky so that you can come to a realization. But chances are, just by looking at your code, you can find a few things. For example, here, notice that I'm calling this function every time inside the loop. Maybe I can bring it outside of the loop and just call it once and use its result in the loop without calling it over and over again. While you are thinking about this, your interviewer might ask you a very simple question, which can be something like, can you improve your search? Notice that this innocent looking question can put you in a very special and important position, which is you have to address it. And that brings me to my next tip, which is take hints seriously. Whenever the interviewer asks you a question, give you a comment, or maybe explicitly give you a hint or feedback, that means your job from that moment on is to consider and address the comment or answer to your question. Questions like this are usually not just a question, but they're also a hint. So once you get a hint, either directly or indirectly, your job is to take it extremely seriously and address it at all costs. And the reason is that if you don't take them seriously, if you don't address the hints, the interviewer might add a feedback note like this, which is, I gave them a hint, however, the candidate was unable to improve the solution. And even worse, they might even throw something like this, which is, the candidate doesn't have good teamwork skills and they cannot communicate. So I'd like to urge you to take all of these questions and comments very seriously and try to focus on them and address them. Now, in this case, when they ask us to improve our search, one observation that you can do here is that we are going through numbers from 0 to 2n minus 2, and we are testing something for each number. And this is one of the classic cases that instead of a linear search, which runs n times in the worst case, you can move on to binary search instead and go from a linear search to something that is log of n. And also, you guessed it right, as soon as you come with this insight, it's best to write it down so that in case you ran out of time and you were not able to implement it, at least you get some credit for it in your notes. And also, as we talked before, you can bring this create mod grid outside of this loop so that you create this grid only once and don't repeat the task over and over again. And again, write down the improvement idea here before you implement it. Now let's move on and see what should we do for bringing this function outside. Notice that what we really need to do is to find the minimum distance to all sharks at each entry point on the grid. So from this original grid, we should move to something like this that has the minimum distance to each shark in the grid as a number. For example, this point, the minimum distance is 0. At these points, the minimum distance is 1. And at this point, the distance to this shark is 2, the distance to this shark is 4, and the minimum is 2. So we have to put 2 here. So the input of our function is this grid. It's a two-dimensional vector of characters. And the output is this one, which is a two-dimensional vector of integers. Notice that we can create this new grid from the original grid by running yet another BFS, breadth first search, in which you first add all the sharks to the queue with distance 0, and then continue running BFS as you would normally do. Since in a grid like this, BFS inherently finds the shortest distance, and since we started from all of these sharks at the same time, the numbers that you would get would be the minimum distance from all the sharks. And notice that my function doesn't have I as an input anymore. It's just the two-dimensional vector of characters. And since I changed this function slightly, I also have to change my BFS function to take one extra input here, which is I, which tells the BFS algorithm which entries should be considered blocked. More specifically, this function now checks if a path from start to end only using locations with value greater than I exist. So BFS should look at this grid, which we only create once. Each time it takes an I, and it returns true if there is a path from start to end, only using entries whose value is greater than to input I. If such a path exists, it returns true, otherwise it returns false. When I is equal to 0, our BFS function should consider these 2 points to be blocked, and when I is equal to 1, it should consider all these points and these points are blocked. And one great thing about changing and modifying these functions is that we haven't still implemented them. We just changed their signature without implementing them. So this didn't take that long of a time. Moving on to our algorithm, now we have a simple binary search. So we call our create modified graph once with the modified signatures that we talked about before. We take start, end, and modified input as an output of this function. And then we have a simple binary search that starts from 0 and goes all the way to 2n minus 2 and tries to find what is the maximum value in this range for which BFS returns true. And again, I want to emphasize from tip number 0 that you have to mostly rely on your memory for writing a simple algorithm, a famous algorithm like binary search. There's no time to think about how binary search works at the interview session. So you have to be very comfortable with it. You have to rely mostly on your memory so that you can write this pretty quickly. Now, once you're done with this, then update the runtime complexity to its new value, which is now log of n multiplied by n squared. Because the binary search is executed log of n times, and each time it's running BFS, which has O of n squared. Before I move on, I should mention this is not exactly a correct code. There is an intentional bug in my implementation, which I will address in the next few minutes. However, notice that even if there are small bugs in your code, at this point in the interview, you should probably get these feedback notes, which is the candidate was able to improve the algorithm by moving the BFS outside of the loop. They were able to use binary search and they were able to correctly calculate the runtime. Notice that at this point, you have a lot of positive points, and this is a very good position to be, even if your code has small errors. And that brings me to the next part, which is you are not done yet. Let's go to tip number 18, which is test your algorithm on all of your examples and make sure your algorithm runs and produces correct answer on all of them. And notice that as you're testing your algorithm, run it on smaller size examples so that the whole process is more manageable. Or at least start from smaller size examples. Once you're sure it works on them, then move on to bigger size examples. So let's move on to test our algorithm. Let's first consider this easy case where our grid is 3 by 3 and there's no shocks. That means every element in the modified grid will have the value 2n minus 2, which would be 4. So what you need to do is to follow your algorithm, follow the values of the variables, and see what the output of your algorithm is for this case. The values are initially left is 0, r is 4, and mid is 0. Next, mid is equal to half of r plus l, which would be 2, and is passed to our BFS algorithm. Since the value of mid is 2 and everything in this grid is 4, BFS passes, and that will update l to 3. Up next, mid becomes 3, and then we run BFS again, which again returns true. That makes L is equal to 4. And finally, we set mid to 4 and we run BFS one last time. This time with parameter 4, BFS returns false, and that makes R to be 3. As a result, we exit this while loop and then we return mid, whose value is 4. And as you know, the expected value in this case from your function is also 4. So this case passes and we are good. Let's move on to a case that we only have one shark. So the output of create mod graph is something like this. And again, we start with L equal to 0, R is equal to 4, and mid is equal to 0. Inside the loop, we update mid to 4, which then is passed to this BFS algorithm, and with value 2, BFS would not pass because the value of this location is 2, and our BFS algorithm requires all the elements on the path to have a value greater than this last parameter, which is not the case here. So it returns false. As a result, R becomes 1. Next, mid becomes 0. This time, BFS passes, and as a result, L becomes 1. And finally, mid becomes 1. Again, BFS passes. As a result, R is updated to 1. And this causes the while loop to terminate. And the output of our function is 1, which, as you can see, unfortunately, is not the value that we expected, which is 2. We did expect for you to simply swing from here to here, and the minimum value along this path is 2, so that should have been returned. However, the output of our algorithm is 1. So this means, as I mentioned before, there is a bug in this algorithm. Looking at the algorithm again, notice that we are updating this mid value irrespective of what BFS returns, and then at the end, we return mid. However, what we should really have done is to update the output of our function only if this BFS passes. So to fix this issue, what you can do is to add a new variable, call it output, and update it only BFS passes with value of mid. If BFS passes with value of mid, that means our output is at least mid plus 1. And then at the end, we return output instead of mid. With this fix, again, you need to test your algorithm. So again, we start from the initial values for L, R, mid and output to be 0, 4, 0, and 0. The first iteration inside the loop, mid is updated to 2. BFS does not pass with mid is equal to 2, so that updates R to 1. In the next iteration, mid is updated to 0. That makes BFS pass, so that updates L to 1. Next, mid becomes 1, which passes BFS. So output is updated to 2, and R being 1, L being 2, terminates this loop, and finally we return 2, which was the value that was expected. So this case is now passing. Let's look at the impossible case where the output is surrounded by 2 sharks and the expected output is 0, because you either have to cross this entry or this entry, which makes your minimum distance to any shark to be 0. So our algorithm starts with L is equal to 0, R is equal to 4, mid and output are equal to 0. In the first iteration, mid becomes 2. With value 2, BFS fails, so output stays at 0 and R becomes 1. In the next iteration, mid becomes 0. Again, BFS fails, so the output stays at 0 and R becomes minus 1. R being less than L at minus 1 terminates this loop and we return output, which is 0, and it is equal to the expected value, which was 0. So this case is also passing. And finally, let's check one last corner case where the input is an empty grid. So the size of our input is 0, the grid is empty. So in this case, we should expect the minimum distance to be the lowest value, which is 0. Size being 0 makes R to be minus 2, mid is 0, and output is also 0. Since R is minus 2, this condition is never met, so we never run the loop and we return the value of output, which is 0, which is exactly what we expected. So this case also passes. And that brings me to tip number 19, which is make sure that you did not forget any other corner cases which was not included in your initial examples. Going back to the interviewer notes, hopefully you will have something like this, which says you were able to test your algorithm on multiple inputs, and not only that, but you were also able to fix a bug. Notice how many positive points you have here. You were able to successfully run the algorithm. The algorithm works, it generates the correct output. You were able to improve it. You were able to calculate the runtime correctly. You were able to fix the bugs. You were able to test it. So if this doesn't get you hired, I don't know what will. Up next, notice that you still may not be done. If there's more time, the interviewer might be willing to ask you follow-up questions. Some follow-up questions that they might ask you here are, what if you also want to return the actual path? Right now, we only return the maximum of the minimum distance. What if we actually want to return the path as well? Another question would be, what if you use DFS instead of BFS? We know that DFS can also find if a path exists between start and end. Why did you use BFS? What would happen if you use DFS? What are the pros and cons? Another question would be, what if there are multiple islands? In this case, we only had one. What if you have multiple and you want to swim to one of them? And I should add one more question here, which is, we use BFS and binary search. I will leave that to you guys as a homework assignment to see if there is any other algorithm that you can apply that can get to a correct solution and see if that algorithm would have been more efficient than the one that I provided. The bottom line here is at tip number 20, welcome follow-up questions. Follow-up questions mean you did well, and they can potentially add up to your feedback notes, the positive feedback notes, and they can make you stand out among all other candidates who were also able to give the interviewer a correct answer. So if you know your basics, if you're ready and you have practiced, you should not be scared of follow-up questions. Now, before I let you go, let's put everything all together and recap all the tips that I mentioned. First, let's talk about how, in general, you should approach a problem and how you should solve a problem that you haven't seen before. The first step was to specify input and output accurately, which means at this point you should have the signature of your function. Up next, create examples. As you create examples, make sure you consider easy, hard, and corner cases, and also make sure you keep your examples manageable. Chances are some examples are already given to you, but there's no harm in generating your own, especially if you need an easy example and a manageable one. Now, hopefully, these examples will give you some insight, which you can use for the next step, which is propose and implement an algorithm. As you're doing this, try to write a modular code and also iterate through your knowledge to find out which algorithm that you know, which data structure that you know can be applied here and solve the problem for you. In the absence of any insight, maybe you can consider brute force or some very inefficient solution with the hope that it will give you some insight for an improved one. And also, if nothing else, at the end of the interview, you were able to at least produce one solution that is not efficient. An inefficient solution is better than no solution. Next, make sure you take any hints from your interviewer very seriously and address it. And finally, keep in mind that if your solution seems to be too long, if you feel like the solution that you have in mind might take 100 or 200 lines, chances are you're not on the right track and there must be something wrong. So hopefully, once you create a solution, the next step is to test it and also calculate the worst case runtime complexity and make sure that you write everything down. Next step would be propose and implement improvements. Maybe you can use a better data structure. Maybe a heap, a tree, a binary search tree, a map can help you. Or maybe you can use some sort of pre-calculation. Pre-calculate something so that you don't have to calculate it over and over again. Maybe you can sort or index your data so that it can be found or accessed easier. Maybe you can come up with a better searching algorithm. For example, in this case, we went from a linear search to binary search. And finally, maybe you can use an optimization technique like dynamic programming or backtracking that allow you to get to a faster runtime. Again, hopefully, once you're done with this step, the next one would be to test your algorithm and also calculate the runtime complexity. Up next, I have been talking about the time of the interview. Usually, you're given about 45 minutes to 60 minutes to solve a problem. Make sure you schedule it wisely and make sure you take advantage of your time wisely. In my opinion, the greetings and chit-chat should only take about 0 to 2 minutes and not more. You should try to get to your problem as soon as possible. Next step is to understand your question, ask clarifying questions, and get to your function signature as fast as you can. Hopefully, you can finish this in 2 or 5 minutes. Next step would be creating examples. Sometimes they're given to you, and sometimes you have to create your own examples. Hopefully, you can do this also in about 2 to 3 minutes. The next step would be proposing and implement your algorithm and testing it. Hopefully, this can take somewhere between 10 to 25 minutes. Sometimes it might take even longer, sometimes it might take shorter. If you get lucky and you can finish it quickly, then you can get to the next step, which would be improvements to your algorithm, followed by more testing. Hopefully, you can do this in about 5 to 10 minutes. Whatever remains at the end would be the time to implement all the black box functions. For example, the BFS function that we have been talking about. The remaining time at the end should be specified to write them down. And hopefully, since you're relying on your memory, you should be able to implement them really quickly. And finally, if there's more time, that should be allocated to follow-up questions. And hopefully, they will ask you some, and hopefully, you can answer them to add up to your feedback notes. Let's talk about one more thing, which is a very common problem, which is, what if I'm stuck? What can you do if you get stuck in the middle of the interview? I'm going to give you some tips, and hopefully, they can help you. First thing you can do is to use your examples. Go over your examples and see if you can find a solution for the very simple case. For the simplest case among your examples, can you create an algorithm? The other thing that you should do is to double check your understanding of the problem statement with your interviewer. Chances are you misunderstood the question and you're thinking about something that is much harder than what is asked from you. If you're still stuck, look for hints, comments, and questions from your interviewer or in the problem statement. Sometimes there are some subtle things in the problem statement or what the interviewer is saying that you can use as a hint, which can provide you some insights. Another thing that you can do is to just iterate through your knowledge. Try to think about all the algorithms, all the common algorithms that you know, and see which one has a chance to provide a solution. If you're still stuck, think about brute force or a very inefficient solution. As I mentioned before, an inefficient solution is better than no solution, and chances are, once you write it, it gives you some insight so that you can improve it and get to an efficient solution. Sometimes, however, even this doesn't work and you're still stuck. In that case, maybe you can explicitly ask for a hint. Maybe you can go back to your interviewer and say, hey, I have no idea, give me some hint. Or maybe you can black box some part of the algorithm and just call it as a function. You can tell your interviewer, hey, I don't know how to implement this part, but assuming that part is solved, now I can write a high-level algorithm and call that function as a black box. In the absence of anything else, there's nothing wrong with providing an incomplete solution. As I mentioned before, an incomplete solution is better than no solutions at all. And finally, and the most important one, whatever happens, do not give up. Go back and repeat all these steps. Hopefully, it will give you some insight. Maybe you can tell the interviewers to give you 1 or 2 minutes. Maybe you can just focus, close your eyes for 30 seconds, for a minute, and get back to the interview and look for insights. And that brings me to my final tip, the most important one, tip number 21, which is, this is your interview. No matter what happens, no matter what goes wrong, do not give up. Notice that a lot of things can go wrong. Your interviewer might be confused, they might be rude, they might be inexperienced, they might be late, or they might have a completely different accent, which make them hard for you to understand. I personally had all of them. I had an interviewer who was very inexperienced and they got confused in the middle of the interview about their own problem, about the solution that I provided. And I had to spend several minutes just to explain and re-explain to them what I am talking about. In another occasion, I had an interviewer who was just late. And as a result, I lost 15 minutes of my 45-minute slot and I had to live with it. On another occasion, I had an interviewer who was pronouncing a word completely differently than what I was used to, and no matter how many times they repeated the word, I was not able to understand them. So finally, I ended up asking them to type that word and spell it out for me, write it down for me, and eventually I was able to understand and we moved on. The point being, these problems can happen. It happens to all of us. The important thing is not to give up and just adapt and move on. That should be your mentality. In another occasion, I was doing a phone interview and in the middle of it, my connection was dropped. It took me 1 or 2 minutes to redial back in and continue my interview. So as a result, I lost about 2 minutes, which was not the end of the world, and I was able to live with it. And finally, your brain might freeze and just refuse to think, refuse to continue. If this happens, understand that this is a common problem. It happens to all of us. Hopefully, it doesn't happen to you in your most important interview. But if it happens, again, do not give up. Maybe you can ask your interviewer to give you 30 seconds, to give you 1 minute, to just cool down, close your eyes, focus, meditate, take a glass of water, and get back to your interview and continue. They do want to see you under pressure. They do expect to see your brain under pressure. So these problems are expected. What's important is for you to keep going. Even if you lost 10 minutes, 15 minutes, you can still get back and move on and finish the problem as much as you can. You need to fight until the last minute in your interview time slot. Let's recap this in a bonus tip, tip number 22. You should fight until the last minute. And whatever happens, adjust and move on. Once the interview is finished, you can always go and complain to your friend, cry, or complain to your recruiter, or maybe you can ask for another chance. During the interview, you should fight on. In summary, we talked about several things. Before the interview, make sure you know your basics and you study the basic and common algorithms and data structures. Make sure you practice mock interviews and make sure you experience some real interviews before you go to the company that you're very interested. During the interview, you should make sure you get to coding as fast as possible. You will not get in unless you write acceptable code. Try to manage your time so that you allocate most of your time to coding. Also, don't forget to take notes of everything. Divide it into multiple sections that capture your assumptions, examples, insights, improvements, and tests. Also, try to turn the table around and make it a technical discussion, not just a monotonic interview. In general, have the mentality that welcomes questions and is not scared of them. More questions means more feedback notes, which means they have more data points to make a decision about you. And finally, make sure you organize your time. Start by providing some examples, then try to provide a solution. It doesn't have to be perfect. You can start from something inefficient and then improve it later. As you're doing this, you can use black box functions and leave the implementation of them for later. Test and calculate the runtime complexity of your algorithm. Once this is done, think about some improvements. And if you were able to improve your algorithm, you have to go back and test and calculate the runtime again. Once you're done with these steps, go back and implement the functions that you use them as black boxes before and complete your code. And finally, hopefully you can leave some room for follow-up questions. Thank you everyone for watching this video. If you feel like you learned something, please support my channel by liking this video, subscribing to my channel, and also sharing the video with your friends. Also, if there's any other tip that you can think of, if there was anything that was useful to you, please go ahead and share that in comments. I would love to know what worked for you guys. Good luck on your coding interviews, and hopefully I can see you in my next videos.